So we're now going to continue our discussion of the Java Executor Completion Service, focusing on the key methods that are defined in this class. And these methods, of course, are all implemented by inheriting from the completion service interface. And we're also going to take a look and see how the Executor Completion Service works in practice by visualizing the way in which multiple client threads can go ahead and submit work to the Executor Completion Service instance, and then let those tasks that are submitted be processed in a pool of threads, and then we'll have another group of threads that are used to get the results as they finish up. There's only a handful of methods defined in the completion service interface. It's actually a very simple interface for if you look at it in the grand scheme of things. One of the types of methods that it provides is the ability to submit a task for execution. And of course, the execution here is going to be asynchronous execution. And even though it returns a future by calling submit, that future is typically ignored. And you'll see why in a second when we look at some of the other methods that are part of the interface. So there's a couple different types of methods that you can have. The first method can be used to submit a value returning two-way task. And this is done by using a callable. And the callable parameter, as you probably remember from the executor service discussion, essentially allows you to give some work to do, and then it returns a value as a result of doing the work. So you can see here that the interface for callable has a call method that returns a generic type V. So you can pass a value back. And of course, the value's result will come back through the completed future through the Executor Completion Service's completion queue, as we'll see in just a moment. This provides what's called the asynchronous future processing model. So even though the future is typically ignored from submit, the way in which the results are processed depends on the order in which they complete, not the order in which you wait for them to complete. So that's a very important distinction between Executor Completion Service and the more basic Executor Service we looked at before. In particular, there's no need to block on the future. Again, you don't typically take the future that comes back from submit and do anything with it. But the way that things work is that there'll be another method that we'll see called take that you can use to wait for the first completed task to finish, or the next completed task to finish, if you will. And there's no need to block on that future, even though you block on take, because by the time it gets put into the completion queue, it's guaranteed to be completed, either successfully or unsuccessfully. The main reason that there's a future passed back from submit is so that you can cancel the asynchronous computation. So you don't typically wait on that future, but you could use it to cancel it if you so desire. The second submit method takes a runnable, and this is not nearly as widely used as the two-way method that takes the callable. As you probably remember, a runnable is just a one-way task that doesn't return any result. And here's what the interface looks like. As you can see, it just has a run method that returns nothing. So this is also a functional interface, just like callable, but there's no way to get the value back without having some kind of side effect through queues or some other mechanisms, which is beyond the scope of this discussion. So those are the ways you submit tasks, two-way tasks and one-way tasks. Let's now talk about ways in which you get the results back after they complete running asynchronously. And as you can see, there are three methods that the Executor Completion Service provides to do this, all of which, of course, are implemented from the completion service interface that Executor Completion Service implements. And here's the methods. It's take and then two different variants of poll. And all these methods use an internal queue, which is a blocking queue that contains queuing future instances representing tasks that have completed, either successfully or unsuccessfully. So once you get back a future from calling take or one of the two poll variants, the get call on that future will never block, because the only way that a future gets onto the completion queue is, as the name suggests, if that future has already completed. So once take returns the next future, it's guaranteed to have been finished. So it won't block. So let's first take a look at take. So take blocks until a future for the next completed task is available, and then it retrieves and removes it. Poll, or the version of poll that takes no parameters, will retrieve and remove a future for the next completed task if there's one available right when you call poll, or it'll simply return null if there are no results at that point. So we're just checking it. We're not trying to block. It's a non-blocking get operation, essentially, or retrieve operation, essentially. And then the third method here, the second variant of poll, will block up to the specified wait time if the future is not immediately available. So if it is immediately available, then it'll give it back to you. Otherwise, it'll wait up to that time amount. And if it doesn't get it, it'll then go ahead and return, which means it timed out. Let's take a look at how to visualize the behavior of the executor completion service. And I really like this style of describing things because I'm a visual person. And sometimes if you just look at APIs and source code, it's kind of hard to know what's going on under the scenes or behind the scenes. So as you can see here, we're going to use an executor to run the tasks. And then these tasks are added to the internal blocking queue as they complete, in the order that they complete. And that way they can be retrieved immediately as soon as they're ready to go. So you can see here that we're going to have the basic architecture shown here. On the right-hand side of the screen, we have the executor completion service instance, and it's got some methods like submit and take. And then internally, it's got a completion queue that it'll use for the results when they're finished. Likewise, it also keeps track of the executor that's passed to it, which for this example will be a thread pool executor with a group of worker threads. It could be a fixed size pool. It could be a cached thread pool. That really is an implementation detail for you to decide when you create the executor that's going to be associated with the executor completion service instance. And so I'm just kind of peeking in and showing you what things look like inside the thread pool executor. And we'll look more about that as we go through the example. And then on the left-hand side of the screen, we've got a bunch of threads, and some of them will be submitting and some of them will be taking. And they could alternate going back and forth, no problem. So in a nutshell, we have one or more threads submitting two-way tasks, two-way async tasks to the thread pool. And then we have one or more threads that are handling the results of these tasks. And oh, by the way, we also have one or more threads that are going to be used in the thread pool itself to process the tasks that are being sent to it or submitted to it. So let's kind of start out, set the wheels in motion. At step one, a client thread submits a two-way task using submit with, let's say, a callable instance. And that submit method is then going to be wrapped up in something called a queuing future. We'll talk more about that shortly. And then we go ahead and the internals of the framework will then call execute with that encapsulated task that was passed in by the client. And that gets put onto the work queue. And then one of the threads in the pool will notice that there's a new piece of work on the queue, and it'll go ahead and take the item off the queue and run it. And it does its thing. It runs the task asynchronously in the background in a thread in the thread pool. And then when it's finished, it will call the done hook method on the queuing future. And what the done hook method will do, as we'll see shortly, is it'll go ahead and add the result, in other words, the result of running the computation, onto the completion queue as a completed future. And that means that when a client thread calls take, it will block until there's something on the queue. And if there is something on the queue at that point, it'll return the future containing the result of that computation. And of course, it returns a future because the computation might have failed, in which case the future will provide the appropriate information indicating why the failure occurred. For example, some type of exception may have occurred. So that's a quick overview of the key methods in the Java Executor Completion Service. As you can see, it's really quite a simple API. And the nice thing about it is it really cleans up the programming that you need to do in order to do asynchronous computations of two-way tasks. Because you, the application developer, no longer need to create your own queue of futures and then wait for them to finish. And you'll get a chance to play around with this when you do assignment 3A, which, as you'll see, is nice and clean and greatly reduces the amount of code you have to write relative to assignment 2A. And for that reason, assignment 3A will not take very long to implement because it will be very, very simple to do.